This is lesson 2.4, electron configuration. So remember back to Gen Chem, electron configuration. Electrons arrange themselves in specific orders in an atom, and each energy level 1, 2, 3, 4, etc., can hold 2 n squared electrons. So if n is the energy level, for example, energy level 1 can only hold 2 electrons, because 1 squared is 1 times 2 is 2. In energy level 2, you have 2 squared is 4 times 2, so energy level 2 can hold 8 electrons, and so on. So here's an example for the third energy level. The third energy level can hold 18 electrons because it can hold 2 s electrons, 6 p electrons, 10 d electrons, which adds up to 18. Remember, s can only contain 2 electrons, p can only contain 6, d can only contain 10, and f can only contain 14. So, Heisenberg's uncertainty principle, remember Heisenberg said that we cannot know where an electron is at any given moment in time. The best we can hope for is a probability of where the electron is likely to be. So, the problem with electron configuration is that it doesn't really explain the geometry of molecules. And so, if we look at s orbitals are spherical in shape, and according to Heisenberg, we say that electrons can be found in this spherical shape with a 90% probability. P, of course, are the dumbbell shape. Remember, there's 3 different p orbitals, each point along a different axis. That's why there's 3. The d atomic orbitals are clover shaped and irregular, meaning that this d atomic orbital is not clover shaped. You can see there are 4 clover shaped all along different axes. And then the 5th is this dumbbell shape with a donut encircling it. The F atomic orbitals are 7. There's 7 of them, and you're not required to know these shapes because they get way too complicated. There are also 3 rules for filling electrons that you need to remember. The first is the Pauli exclusion principle, which states that no more than 2 electrons can be in any orbital, and that if 2 electrons are in the same orbital, they must spin in opposite directions. The Aufbau principle says that electrons are placed in orbitals of lowest energy first. And finally, Hund's rule, which says that electrons must occupy separate orbitals of the same energy before they pair up, because otherwise there's too many electron-electron repulsions. So make sure that you go back and review how to do shorthand notation for electron configuration, which is the shortcut. Remember that 3D is always written before 4S. And remember that there are 2 common exceptions to electron configuration, which include chromium. As you can see, chromium has 3d electrons before it has a 4s, but the 3d are not completely full. And again, copper, 3d10, 4s1. Electron configuration of ions, remember that if you're removing electrons to form a cation, you always remove the 4s electrons before the 3d, even though they fill in the opposite order. And finally, remember this picture. You can easily read the electron configuration of an element by just looking at the periodic table and where they're placed.